Hi, welcome. This is hopefully going to be an introductory video to my endeavours of recommissioning a hydro system where we live, which it's been here for quite a long time. It's probably been here for 50, 60 years. It's been documented on the boundary maps for at least since the 70s. Originally it wasn't at this site, it was somewhere else, and it's been retrofitted to this location. That retrofit has degraded beyond serviceability now. So we don't have a grid connection where we live. We've got solar panels. We've got about a 1.5 kilowatt array, which is fine in the summer. It's good in the summer. It covers everything that we need for now. As we get more established here, we haven't been here that long. I think I'll expand that array, but that's a whole different project. But in the winter, we're not going to really generate very much electricity at all, because the location we are in the valley, we don't get any sun for about 4 months of the year. So that's where this is going to come in. This is going to be running during those 4 months when we don't have direct sunlight on the house and on the array. It probably will run a little bit in the summer. We'll be able to control how much it's running, but what I don't want to do is take too much water out of the little stream that is the power source for it. Time has taken its toll on this, and one of the things I will be doing is probably taking this down and making something nicer, a bit of timber framing maybe. For now, it's keeping everything dry still, it's protected from the elements, it's quite sheltered here. So this is sort of just going to be a sort of video documentation of my endeavours with it. I'm not a hydro systems engineer, I'm actually a film prop maker. I used to be a film prop maker, mostly I just sit at a desk now. I do have practical skills, and maybe one or two of those skills will be applicable to what I'm doing here. It's a really nice bit of kit that's in there. It's too big, but it's what we have. It's what I'm going to use. If I can't get it to work, then I'll have to rethink the whole thing. But it would be lovely to have that making electricity for us. It's 100 years old-ish. It's been here for 50 years. It'll be here for another 100 years, 200 years, if it's looked after. So I sort of want to give it the respect. No. So I sort of want to give it its chance to sort of ride again, as it were. Let's go take a look, and I'll talk some more about what it is, where it's from, and how I'm going to go about making it work again. Here's the turbine. It is a Gilkes and Gordon Limited. It was made in Kendal in England in 1929. That makes it, what, like 96 years old? Gilkes, the company, still exists, and they still have records of all the installations that they've done throughout their existence as a company, way back into, I think, even the sort of 1800s, into the 19th century. So I rang them up, I got in contact with them, and the chap I spoke to has been really, really helpful. All companies should be like this. He sent me through the order book, and that outlines the sort of design specifications of this turbine, and I've got them written down here. So the original power output for it was 12.5 horsepower, which translates to between 9 and 10 kilowatts output. The fall, the column is called fall. I think that can translate to head, was 215 feet. That's the height above the turbine that the source is extracted from. So it's sort of the potential it's the potential energy that's in the water from highest to lowest point into the turbine. And that was 215 feet, which is about 65 meters. It's a Pelton wheel. I should have said that earlier. The size of the runner is 18 inches. So the original diameter of the penstock, the pipe that fed it, was 4 inches. But the next value is the Q value. That is flow. There's no units for that, but I think it's in cubic feet a minute, and that's 39. And the RPM of it is listed as 850. It also lists the location that it was installed and the individuals or sort of organisations that bought all the, bought them. It's from a hotel. It's actually a hotel. It's the hotel that my parents had their honeymoon in, which is pure coincidence. That's a nice bit of sort of serendipity. So there are the specifications of it. The power, its intended power, is too big for this site. I've done some sort of very rudimentary measurements of the head and the flow. The head, just going by contours on a map, is about 35 meters, and measured the flow at, we just entered July. I've measured the flow at about 6.5 litres a second. In winter, that I could go up to 20, I think. It can be quite wild in winter. I think I'm only probably going to really run it in winter. I don't want to drain the little stream in summer because we've got the solar panels to be our primary source of electricity. We could maybe power it up every now and then. We also have a diesel generator, so that's the other option. My flow estimates are between 6 and 10 litres per second, and the limiting factor of the high end of that flow is the penstock that is sort of here at the moment. When this was first installed on this site, I think the penstock, I measured it, it was about maybe 5.5 to 6 inches, the inner bore of that. The penstock that has been put in more recently in the last sort of 10-20 years is this. It's a much smaller schedule. It's 90 millimeters. That's going to be the limiting factor of how much energy we can extract from this. I could go to the effort of taking proper measurements of the head, but I'm not going to bother. What I'm going to do is I'm going to put a pressure gauge on this penstock, and that will give me the static pressure, and from that I can work out exactly what the there's two measurements for head. There's the literal height, and then there's what's known as net head, which is the actual true value of what that pressure is after the losses of friction in the pipe. There's a lot of maths with hydro, and if this was a new installation, then I'd be going to a lot of trouble of setting everything out and making sure everything had the highest level of efficiency possible. But that isn't what this project is, because so much has been done before me coming to it that I'm just working with what I've got. It could be, once it's running, if we think we could get 50% more power by popping in a new pipe, which I think we probably could, if we need it, then I'll go ahead and do that retroactively. But for now, I'm just going to work with sort of everything that's here and make it work. What else is on my little... Actually, I should go over what we have here, what the various components are. It's very simple, and also what it's missing. This is the turbine housing. Within here is what's known as the runner. I said it's an 18-inch runner, and it's a Pelton runner, which means it's got it's like a disc with lots of little spoons on, and water hits those spoons and imparts its energy onto them and makes it spin. This is the output pulley. It's a V-belt pulley. This is the spare valve. This water comes in here, and this regulates the flow of that water as it hits the Pelton spoons. As you undo that, more water comes out and makes it run faster. And over here, hopefully the camera's picking that up. Maybe I'll move the camera. This here is the governor. This is it's essentially a speed regulator. To put it simply, as the turbine gets faster, this actuates a series of linkages here and makes this turn, and this in turn and this is connected to there's a vane in here, and that basically just deflects water away from the runner the faster it goes. So the faster this goes, the more it moves that vane, and the more it deflects water away from it, and essentially slows it down. It's like a speed regulating system. I'll talk more about my plans for this particular part of it in a moment. I was going to do a silly little bit where I spray easy start at it and ask the question, will it run? But the simple answer to that question is, yeah, it'll run. It's all been well looked after. All this is coming up on camera. These are all grease reservoirs, and they're all full. All the bearings seem really good. There's no clay in it. There's a tiny bit of clay in it, but nothing to write home about. Cosmetically, it needs a bit of a tidy up, but it's all pretty sturdy, and it's all well put together. I'm going to take it apart. The chap that I spoke to at Gilkes said that they still have records of all the original drawings in their paper archives. Hopefully he'll get back to me with those drawings, and it'll sort of remove some of the shrouds of mystery around a couple of the components, or the way it was set up when it was first running. So I didn't actually talk about what's missing, and what's missing is the means of actually extracting electricity from the kinetic movement of this. What was on here was a massive great alternator, which is currently a garden ornament, rotting away in the garden. That's well out of service. What is on here currently is a teeny tiny little alternator out of a car. The previous endeavours that the people were doing involved headlights and a car battery. I'm not going to be pursuing that. I should just take all this out. So there's two things to talk about here. One is so the original way of controlling the speed of the turbine was with the governor. So instead of the governor being the method of speed control, it's going to be the resistance of the I'm going to use a three-phase motor. It'll be mounted here. I'm going to belt mount it, and that three-phase motor will provide a constant load on the turbine that will provide a resistance to stop it spinning too fast. That's a whole load of research that I need to get into. It needs to be so the solar panels that we have that I talked about earlier, they're an MPPT, maximum power point tracking way of charging. We have batteries. They charge the batteries with MPPT. My controller needs to work in harmony with those solar controllers, and I've done a little bit of research. There is some documentation of people doing it. The main important thing to do is to have a ballast on the charge side of it that will, when the batteries are full and when we're not demanding much electricity from the system, we still need an electrical resistance on the motor so that it doesn't go too fast. And so that'll either be an oil immersion heater, a water heater, or even proper resistors. We'll get into that a bit later on. That's not for now. But just to say, it's not going to be a little car alternator attached to a headlight. Is there anything else to talk about here? What have you seen? The dog's seen something. We have quite a few buzzards flying over. At some point we'll have some chickens, and this aggression can be focused into protection of livestock. But for now, she just alerts us to flying objects in the sky. It's very sweet. Good girl. So I should say, again, I'll go into this more later, but that book is going to be my Bible when it comes to extracting electricity out of this. It'll be a 3-phase motor with a bridge rectifier, and then you need capacitors on it to energize the coils and stuff. I'm basically going to use this as a little Bible, and it should see me through. That's the other main source of information that I'm using. I've got a few different bits of documentation, but this one, Going with the Flow, which is, it's a few years old now. It's by the Centre for Alternative Technology in Wales. That's really good. That's helped demystify a lot of the various elements of small hydro systems. The other thing I should talk about is the way I'm going to integrate the governor into this system. So let's talk about that. So I'm just going to talk a little bit about the governor and what my plan to reintegrate it back into the system is. So I don't think I'm going to use it for speed control, but what I might do, I think I'm going to keep it to, it's obviously been developed to balance everything. So to remove all this big bit of weight, one, I think it's going to help stabilize the turbine as it spins, because it acts as a flywheel. It's really heavy. I think it's weird. I think it's made of cast aluminium. I haven't opened it or anything yet. Anyway, I'm not going to use it to regulate the speed. What I'm going to do is hopefully integrate the vane that's in there as an emergency shut-off. So should the charge controller fail, or should anything stop receiving signal from, say, the batteries or the whatever ballast I have stop working electrically, as a fail-safe, I think if I have this held open with a solenoid, so as long as the system is fine, this thing is held open and the vane is not in the way of the jet of water, everything will run fine. Should there be something go wrong, that solenoid will stop receiving power, will slam shut, and it'll knock the vane into the water, into the stream of water, and it'll basically shut it down and stop it spinning without any load on the other end of it. Yeah, I think that's what I'm going to do with the governor. To be decided. I should talk about what my initial plans are as far as proceeding with the project. So I'm going to look at adapting the pipe that's been put in, and the more modern pipe. I'm not going to change it, even though I think it's a bit small. I'm going to put a pressure gauge on here, and that will give me the reading of static pressure. I talked about that. I'm also going to put a gate valve on here at the bottom, and that will enable me to isolate the turbine from the pressure of the pipe. At the moment, there's no system of control the whole distance between the turbine and where water enters the intake. Then at the top of the pipe, at the intake, I'm going to probably add another valve to turn it on and off up there, and then I'm also going to add either a standpipe or an air release valve, so that there's something there that can control either a vacuum forming in the pipe or air pressure to allow that air to release. So that's gonna, I think, conclude this little introductory video. There's not going to be very much footage or any footage of me actually doing anything to it. It's more just for me to outline, for me, what my goal is. I think explaining it to the camera helps me sort of regiment things in my head and work out what I'm going to do. First plan of attack, I said, it's to work on the penstock. That's a question actually. If in the next week or so I'm going to research the gate valve I need. It's a 90mm SDR17 HDPE pipe, and I either need to use a combination of compression fittings with flanges on a gate valve, or there are manufacturers of gate valves which specifically have HDPE pipe fittings. I can't seem to find anyone in the UK that will sell that to me. If anyone watches this and is able to recommend somewhere or someone that might be able to sell me one of those, that'd be good. Otherwise, hopefully whenever it is that I produce the next bit of footage, there'll be something to show for it, and hopefully it will be making this penstock a little bit more usable. So thank you for watching, I guess, if you made it this far. It's a bit dull, but I think it's quite interesting to get a piece of old heritage machinery, 100 years old, up and running. It will outlive me if I can get it working. This is by no means a set of videos on how to go about surveying a site for hydro installation and achieving peak efficiency from it and all that. It's a piece of history really, to have an opportunity to work on it and get it running and producing electricity for us is really exciting. I'm looking forward to getting stuck into it. Hopefully in the meantime, while I'm getting on with this and working and putting in these valves and all the rest of that nonsense, hopefully the Gilkes representative will get back and we can see some drawings of what this was when it was designed. Thanks for watching, if you've watched all this way, yeah, we'll see how I get on.